Good evening, all of you. This is the 8th session of your class, chapter number 3, Queue and Recursion. So, this is the first slide. First of all, what is queue? Same as like a stack, here also, a queue is the ordered collection of an items where an item is inserted at one end. That end we can call it as a rear end, and an existing item is removed at another end. That end we can call it as a front end, so that it is called as the FIFO, that is first in first out. Q, it is also called as first in first out because it is an the first in first out basis, the concept. Once again, I'll repeat the definition. A queue is an ordered collection of an items wherein an item is inserted at one end. That end we can call it as a rear end, and an existing item is removed at the other end. That end we can call it as a front end. The queue, which is also called as a FIFO, that we can call it as the first in first out basis. Here the insertion are limited to one end of the list. That end is called as a rear end, whereas the deletions are limited to another end. That end we can call it as a front end. So here the diagrammatic representation, the items which are inserted from the end, that end we can call it as a rear end. The item 1, item 2, item 3, item 4 and item 5. These are all the elements, and the deleted from the another end, that end we can call it as a front end. So this is the types of queues. The types can be classified into four types. One is simple queue, second one is a circular queue, third is a priority queue, the last one is DQ, which is also called as a double-ended queue. First, let me know about the first type is simple queues. So what do you mean by simple queue? The simple queue, which is also same concept like the queue. So in the simple queue, in the insertion occurs at the rear end of the list and the deletion is occurs at the front end of the list. This is same as like an ordinary queue. That is also definition of the queue. So this is a diagrammatic representation. 0, 1, 2, 3 up to 8. These are all the indexes of the memory allocations. Here the elements are inserted from the rear end. First, that is a 0, and the second is 1, then 2, then 3, then 4, then 5. These are all the elements like an A, B, C, D and E. The first, the 0 position, the element is deleted, so that the front which is incremented by 1, so that the front is equal to 1, the rear is equal to 5. This is the simple queue concept. Simple queue, that is insertion occurs at the rear end and the deletion is occurs at the front end. The second type is circular queue. A circular queue is a queue in which all the nodes treated as in circular fashion, such that the last node follows the first node. Here is a diagrammatic representation. The last node is an 8, which follows the first node, that is a 0. Here the front position is a 4 and the rear position is a 0. The third type of queue is priority queue. A priority queue is a queue that contains the items having some present priority or the preferences. An item can be inserted or removed from any position depending on some preferences or the priorities. The type of the queue we can call it as an priority queue. The fourth type is double-ended queue. It is also a type of the queue in which the insertions and also deletions takes place at both the ends. So here is a diagrammatic representation. So one side, that is insertion and deletion takes place at both the ends, that is insertions and also deletions. Then let me know about operations on the queue. That is same as like the operations on the stack. Here also the sum of the queue operations are, the first operation is an queue. So it's a function, it creates the new queue. Initially it is an empty. It does not need the parameters and it returns an empty queue. The second operation is an enqueue. It contains the parameter item. So it adds a new item to the rear of the queue. It needs the item and returns nothing. This operation is generally called as push operation. The third operation is a dequeue. It removes the front item from the queue. It does not need the parameter and returns an item. This is also called as a pop operation. The next is an is empty. So it checks whether the queue is empty or not. It does not need the parameter and returns the boolean value. Then size. It returns the number of the items in the queue. It does not need the parameters and returns an integer value. So that the queue, enqueue, dequeue, is empty and size. These are all the sum of the operations on the queue. The next concept is the memory representation of the queue using arrays. The queue is represented in memory as the linear array. Let the queue, it's a pointer. It's a linear queue. It contains the two pointers like the front and rear. The pointer variable front, it contains the location of the element to be removed, and the pointer variable rear, it contains the location of the last element to be inserted. Here also the two conditions are there. The first condition is front is double equal to null. It indicates that queue is empty or not. And the conditions the rear is equal to n. It indicates that the queue is full or not. That is overflow or not. So that this is a diagrammatic representation of the memory representations by using the arrays. The first diagram that shows that the queue, it contains the number of elements like A, B, C and D. The A is a front position and the rear, it is an D, it is the rear positions of the queue. The front is equal to 1, the rear is equal to 4. Then the one more element has to be inserted to this queue at the rear end. So that here rear which is equal to rear plus 1 and the queue of rear which is equal to E. The E is the element that is inserted into the queue. Then the second diagrammatic representations here is so that E is inserted at the rear end at the fifth position, so that the front is equal to 1, the rear is equal to 5. These operations we can call it as an enqueue, which is also called as a push. Then the last diagrammatic representation here is item, that is queue of front, then front which is equal to front plus 1. So here we have to deleting the one element at the front end, so that we have to incrementing the front pointer, so that front which is equal to 2 and rear is equal to 5. Then the second representation, the memory representation of the queue using linked list. Queue are also represented by using the linked list. In queues, an item should be inserted from the rear end and an item should be removed from the front end. The pointer front that contains the location of the first node of the linked list and the another pointer of the rear, it contains the location of the last node. So this is diagrammatic representation. Here it contains the address of the first node, that is 50. Then the second node is a 25, third node is an 20. So that when we have to creating the one more node at the rear end of the linked list concept. So that second diagrammatic representation, we have to inserting the one more node, we have to creating the node and inserting the element, that is 70, then adding to the existing linked list. Then the third diagrammatic representation, we have to deleting the front end of the linked list, that is a 50. This element, this node has to be deleted at the front end of the linked list. So this is the end of the session. Thank you.